you build Pydantic, you build Logfire, and then PydanticAI, and you get into agents, which is completely different field. So how do you get into agents?
We didn't build PydanticAI primarily to be easy to use. What we built it to do was to be type safe and to be good for building production applications.
What's the right way to build an agent framework?
If you go to an experienced engineer and you say, hey, do you want to go and use this drag and drop interface to build your agents? You're going to get punched on the nose. I think there's value in just like doing the thing you care about as well as you can. And sometimes you get lucky, sometimes you don't.
This is probably the most complete LLM course I've seen so far, from beginner to advanced developer by Towards AI. It's basically a one-stop conversion for anyone who wants to become an LLM developer, and the course has over 90 lessons to go from beginner to advanced in the field. It's both very practical and industry focused, but also quite technical, and you will cover a lot of technical topics like RAG, fine-tuning, agents, audio, and caching. So if you're interested, check out the link in the description, and don't forget to use the code AIStories10 to get a 10% discount. All right, hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist at Artifact, and I will be your host. So today, our guest is Samuel Colvin. Samuel is the founder of Pydantic, PydanticAI, and Logfire. He got an MEng in mechanics and fluid dynamics from the University of Cambridge and then had a few experiences. He worked at Schlumberger, Nell Health, and TutorCruncher before starting Pydantic in 2022. So in this episode, we'll talk a lot about Pydantic, about agents, and PydanticAI, about observability as well. If you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, hello Samuel, very happy to have you on the show. The first thing I wanted to ask is, how did everything start? How did you get into this world of AI? How did you get into the field?
Well, first of all, thanks so much for having me. How did I get into the field? I guess I'm lucky in that AI kind of happened to Pydantic, as in Pydantic started as a side project in 2017 before LLMs, and it wasn't designed at all around AI or ML as it would have been then use cases, but gained in popularity a lot. And then obviously was used by Fast API, which increased the usage a fair bit. But then I guess just around when I started the company, which ironically wasn't really started around LLMs, but around the developer experience of Pydantic. Around that time, as I guess ChatGPT 3.5 came out, people started to use Pydantic more and more to both build the JSON schema for tool calling and validate structured outputs and tool calls, but also actually just use Pydantic generally in the SDKs of all of the AI libraries. So I was speaking to Sebastian, who was speaking to the people who were building Stainless API, who were building the OpenAI SDK, and they said, "How should you do it?" And Sebastian said, "Use Pydantic," and so they did. And so obviously that's then OpenAI's SDK, Anthropic's SDK. Now Google's new SDK uses Pydantic, and obviously all of the agent frameworks like LangChain, Llama Index, etc., use Pydantic. So it's become the kind of de facto way of getting structured data out of LLMs, which is why, but without us originally sort of designing it for that. So we've been pulled into AI more than kind of setting out to go that way.
Okay, so before we dive into AI, maybe just understanding a bit more Pydantic, like why did you decide to found Pydantic, create Pydantic, and what is Pydantic for those who still don't know what it is?
Yeah, absolutely. So Pydantic started off in 2017 because type hints were just starting to be a thing in Python. I guess it was Python 3.5. Type hints became PEP, whatever it is, 472 or whatever. Made type hints much more popular. I mean, I know they had been around in some form for a long time, but like that's when they really came to prominence in Python. But it was kind of crazy to me that we had this language where you could define a class or a data class, and you said that user ID is going to be an int, but like by default, you could pass any value in and nothing would fail until you tried to use it. static type checking with MyPy and now Pyrite was good, but at the boundaries of your application, when you're reading API call or a CSV file or user input, obviously those type-ins mean nothing. And so Pydantic started off as an experiment that could we use those type-ins to perform validation, to basically enforce the type-ins that worked, put it up on Hacker News, and it got a bit of popularity. But yeah, it was a like side project, like many others I've done. But it was always growing faster than other side projects. It was always more popular, and it got to taking an hour a week to reply to issues, and then an hour a day to reply to issues, and then beginning of 2022. I was really proud of how widely Pydantic was used, but I wasn't very proud of its internals. It had been written in Python when I knew a lot less about Python. And so I started rewriting the core in Rust, thinking that was going to be a 3-month project. 8 months into that 3-month project, I was like half done. And then I got this amazing email out the blue from Bogomil, from Sequoia, basically asking if I wanted to start a company. So had some meetings with Sequoia and some other VCs, and yeah, started Pydantic, the company, in the last week of 2022. And the first thing we did was go to. So I had always planned to start a company at some point. I wanted to finish Pydantic V2, but that was taking longer. And so the first thing we did once we started the company, I hired particularly people like David Montague and Adrian, who had worked with me on Pydantic, basically the best open source people I could find. And the first thing we did was finish Pydantic V2. We got that out in the middle of 2023. And then we started looking around to work out what we would build commercially.
And so what did you start building commercially then?
So I had actually owned the logfire.dev domain name since 2019. I had been frustrated by what I would then have called logging. In Python, the Sentry is great for what it does, but it's mostly about exceptions. What happens for the rest of my logs? Why can't I use the structured data that I record in my logs to both search and then to display aggregates, right? So if I record the amount on a payment every time I do a log, why can't I build a graph of those values, average or sum over time? And the other thing that kind of happened in the background, I wasn't particularly following at the time, was OpenTelemetry, which is a open standard for how we send logs, traces, and metrics, which I think represents an enormous opportunity to disrupt observability, where I think until Logfire, we have this polar world where we have most people who just get logging, basically. And then we have big organizations with big budgets, and in particular, big DevOps teams who get Datadog and Grafana and the full suite. And so what would it look like to try and give people that same level of fidelity that you get from Datadog, but without the horrendous complexity of setting it up and maybe some of the horrendous cost? But really it's the horrendous complexity that's the blocker for most people. If you're a 2-person team trying to get your app off the ground, you just don't have time to go and do the setup of Datadog. But Logfire is 2 lines of code. Yeah, and you can start getting value, or 5 lines of code, you start getting value, and then you can use it more and more.
And so is it mostly for developer, right? For developers to understand their code better?
So at its essence, at its core, it is a analytical database that has got a needle into the artery of your application. So it gets all the data you want to send it. You can use that for whatever you want. You obviously can use that for working out why your endpoint is slow because you have some database query that doesn't have an index. You can use it to understand what questions people are asking of an LLM, or like I say, if you're recording every payment and the amount, that the numerical value is then stored in the database as a numerical value. You can go and use that to build a chart of payment volume over time, or where people are dropping off in your pipeline. In theory, it's just a database connected to your application with a nice developer experience. And one of the things we've worked really hard on that's been one of the most challenging definitely the most challenging technical part of Logfire is that we allow you to write SQL directly against your data. So instead of having some hamstrung, constrained query language that lets you query it, you can go and write full-on SQL that gets executed on your data. And so you can both search it, but also do the aggregations, do whatever you want.
And so what's behind it? What makes it so powerful? Is it the fact that the logs are better structured than usual logs? How is it so good?
We're actually recording data as almost always as traces. So as OpenTelemetry traces, they appear like logs, but you can effectively click on a log and then dive in and drill down into what happened within that particular task. So HTTP request or LLM call or whatever it might be. That's not like fundamentally new. Traces have been around for a long time, but I think the thing that people always say to us is that like the developer experience, the minimal amount of effort you need to get going, and the value of what you see, and how closely that view links to people's mental image of how their application runs. Seems to really hit home for people. But also, I don't think, with the exception of Sentry, who are great, but they're more at least traditionally around exceptions, there has not been an observability company who have come from the Python world and who have like really tried to make the Python developer experience great. Python is just another language they need to support. It's plays second fiddle to Java and C#, the like big enterprise languages. But we're like Python developers first and foremost. And so we want to make the experience of using Fast API or Flask or SQL Alchemy or whatever tool it is as good as it can possibly be. We've worked really hard to, for example, extract attributes from inside F strings. So if you do logfire.info, then an F string will take out the values from inside the F string. Things like that, like if you're a general purpose observability company, you're like, no way would we do that. We're covering 20 languages. Yeah.
And so you said it's very simple to set up. How do you set it up?
Yes. So where we're different from other observability companies, is that we have our own SDK. So if you look at how most companies now suggest you do observability, is go and install the OpenTelemetry SDK. OpenTelemetry SDK, again, OpenTelemetry is an open source project that's trying to cover 20 or 30 languages. The SDK is not particularly easy to set up. I think I tried it, and you need something like 35 lines of code to get basically Hello World working. And that is not simple code. It's like connecting your trace provider to your batch exporter, and that's for tracing, and then you need to do the same for metrics, and if you're using logs, the same. Whereas with Logfire, we have the SDK Logfire, so pip install Logfire, import Logfire, Logfire configure, and then you can start using it. So logfire.info or logfire.span to do a context manager around some code. If you're using any popular library, you would do, say, logfire.instrument fast API or instrument Flask, instrument HTTPX, instrument OpenAI, etc., etc. So that, like the experience from the Python developer just trying to get something into the application is, we've heard lots of times, markedly different from what it would be with other platforms. And then on the other end, the fidelity of the data you get out is different as well, because we're letting you use the tools you already know, like SQL. So you can go and build a dashboard by writing SQL without having to learn some new domain-specific language. Or if you want to go and get that data out to go and do your own analytics, say to like power your evals, you can write SQL and query our database directly and effectively get back the data and build your own application, again, on top of Logfire as if it's just a database.
Okay, so quite powerful. And okay, so you build Pydantic, you build Logfire, and then PydanticAI, and you get into agents, which is, I would say, quite surprising. Like, it's really a completely different field. So how do you get into agents?
Yeah, I'd actually say in some ways it's the other way around. In some ways, like PydanticAI is much closer to what people know Pydantic for than Logfire. Logfire was the bit where people are like, what? They built observability? That's not what they're known for. And that's true, right? We built Logfire because we were like, what's the product you build on top of Pydantic that we as a team would actually use? Well, there isn't an obvious like Pydantic as a service. If you do, like, no one wants validation as a service. There are some use cases around like validation on top of an object store that might be interesting, but like they're not general purpose tools that people want to use. Whereas observability, we wanted to go and build, although it was quite far from Pydantic. PydanticAI is much closer to Pydantic, right? Because we're already used by all of the existing agent frameworks. Pydantic is the kind of lingua franca now for interacting with LLMs. So it made sense, I think, for us to go and build an agent framework. I have enormous respect for the first developers who went and built the first agent frameworks, but they were kind of learning what this news area was. And I think some of those frameworks have the warts of starting early and getting popular very quickly, and are now generally regarded as not having the best of developer experience. So I kind of felt like it was the right time to come along and have our crack at building an agent framework. I mean, if you think about it, the best corollary for LLMs is the internet, right? We had networking around before the internet, but the internet like fundamentally changed everything. If you think about the technology that is now seen as the leading edge of the internet, it wasn't built in 1998. If you look at React or Fast API, Next.js, any of these like leading web frameworks, they took years for people to come along and work out what to build. And that's not because the technology fundamentally changed, right? XHR, which arguably was the last fundamental step change in what you could do with the internet, was 2001. And yet React didn't come out until 2014. And that was just us as a ecosystem, as an industry, working out what people wanted to use. And so it's not surprising that the first agent frameworks aren't the ones that are easiest to use, because we've learned a bunch from them and now we can build better ones. And so if anything, it's probably too early for us to build an agent framework, perhaps, but like, we're a startup, we need to keep moving. And so we went and built PydanticAI with the idea of taking the same high level of engineering competency that I think we have demonstrated with Pydantic, and that we've learned. I mean, I've learned an enormous amount from maintaining a Python package that's downloaded 300 million times a month and used by basically every large company in the world. You learn a bunch of, you get some bruises and you learn things from the scars, and you don't make the same mistakes again. And we wanted to go and take that experience and apply it to Gen AI, because what we realized, particularly in when we had Logfire in open beta last year, was everyone who's building a greenfield project now with Python is using Gen AI, or not everyone, but 80% plus of people. And so we wanted to be able to go and give those people the best developer experience they could. So I think now Logfire is moving more to become effectively a dev tool, or even a DevOps tool for Gen AI. Obviously, the hard bit for us, but the good bit for developers, is to do that well, you have to be general purpose. You have to still instrument PsychoPG and Redis and requests or whatever the other library is, even if they're LLM applications, they're still doing all the normal application stuff. And so you still need to instrument those things properly.
So yes, PydanticAI is an agent framework, and agent is already a vague word. So how do you define an agent framework, and what does PydanticAI really do? Like for me, I see it. I've never built agents, so I see this more as a high level. Yeah, I have more a high level view of it, but I see it more as a framework that lets you interact with an LLM. Obviously, you need an LLM to build an agent framework, and lets the LLM interact with tools or do actions or call other LLMs or other parts of the chain. And I see this more as a chain of LLMs, basically involving tools and actions.
Yeah, I agree entirely with your cynicism about the word agent. But I think people get obsessed about like, what is an agent, and maybe they need to get over that, right? As in, no one, if you say web framework, no one says, but what is the web? What are the boundaries of what defines the web? They just get what a web framework is. And I think we use the word agent framework because that is the go-to term, but you can just think of this as a LLM framework, if that's an easier term to understand. It is a library that tries to do the hard and repetitive work of building applications with LLMs so you don't have to. So the very simplest thing it will do is it will abstract over all of the popular LLMs so that you can try your prompt with Anthropic and OpenAI and Google and Cohere, et cetera, without having to go and change any of your code. You just change the line which defines what model you're using. The next thing that you'll want to go and do once you've got that to work is getting back structured data and tool calls, which are on the same, they're on a spectrum, but they're kind of the same thing. Now, Pydantic is kind of the go-to tool for that already, because if you define a Pydantic model, it will give you the JSON schema, which defines your tool, and then it will validate the response, coerce it if it needs to, and give you back something that's typed. So obviously PydanticAI, built by us, will do that for you as well. But then you can go to the next stage of, if the data, structured data you get back is not valid, what do you do next? Well, the convention is what's called reflection. So you take your exceptions from your validation error from running Pydantic validation, and you send them back to the LLM saying, you got it wrong, here's why it was wrong, please try again. And so instead of you having to go wire up all of that yourself, PydanticAI will automatically take care of those retries with limits, etc. There's a bunch of other steps. So one of the other things is once you start building these applications, they have some strange state within them. They're stochastic. You don't know exactly what they're going to go and do. Right? You can't, in the same way that you can guarantee that a database query is going to return the following result, you can't be that sure with an LLM. And so people have discovered that graphs are really useful when you're building these stochastic systems. I was initially cynical about graphs and finite state machines. I've worked for most of my career without using them, and I wondered about how necessary they were. But I had a few interactions with people who were like, here are real examples of why you would need them. And my answer of like, just use normal flow control if else sounded flatter and flatter as a response. And so eventually I was like, okay, yeah, we need to go build a graph library. But unlike every existing graph library, I want it to be type safe, because this conventional way of doing it, inspired by Network X, where you basically do add edge with the names of the different nodes, is completely untype safe, right? As in your ending, you end up defining these functions, and you're supposed to be clever enough to work out whether the output type or the structure of the state moving from one node to another is correct. Well, I'm not clever enough to do that, and so I want type safety to go and catch that for me. And so we designed a relatively, I think, really quite innovative way of defining graphs where the return type of one node is another node, which therefore has to be type safe, and that defines what node gets called next. So I suspect if you asked an academic who was interested in finite state machines, they would gasp at what we've built. I suspect they would say that's not a finite state machine, that disobeys all of these rules, but it's a heck of a lot easier to go and use. And it's incredibly simple, because all you basically do is call a node, get back a node, call that node, get back a node, and end when you're done. But it still gives you nice things, like you can get a mermaid chart, as in a structured diagram of your graph out. You can decide whereabouts in the graph you want to start executing. All that stuff still works, but in I think, a much more ergonomic way.
And I know like a big challenge in GenAI, and especially with those agentic frameworks where it's not deterministic, and you've got lots of possibilities of things the LLM can do. You've got huge graphs sometimes. Observability and monitoring is like a key issue. So do you essentially incorporate Logfire into that to allow developers to easily understand what happens behind their agent framework?
Yeah, and that's obviously the financial angle for us. Is you can use PydanticAI. Obviously, you're not required to use Logfire, but hell does it get a lot easier, right? As in, what you will discover if you start building something with LLMs is you need observability. Because if you're basically giving the LLM this bunch of tools it can go and call and hoping to get a result back 20 seconds later, you sure need to work out what it did to try and improve, and indeed to work out what went wrong in the case it fails. And so you will need observability. I think that's not up for debate, and we think Logfire can do the best job of that. There's actually there's a complexity, which is that I said we're built on top of OpenTelemetry. OpenTelemetry now has semantic conventions for how you should instrument GenAI applications, which are very new, a bleeding edge at the moment, and we're working now with the GenAI SIG of OpenTelemetry to refine how they work. But we're just about to basically instrument PydanticAI using those GenAI semantic attributes, which will mean that in theory you can take the OpenTelemetry data you get from PydanticAI and send it into any OpenTelemetry platform that will display those attributes. And similarly, because Logfire will be able to display, will be able to correctly render GenAI semantic attributes, you can use any other framework that is instrumented properly within Logfire. Now, that's very early on. So at the moment, I think PydanticAI will be the first agent framework that properly instruments itself with the GenAI attributes, but that's where we're going.
So going back to what you said earlier about, so there were other agent frameworks out there before PydanticAI. There are still many out there. So what's the difference between PydanticAI and other agent framework? And what's the right way to build an agent framework according to you?
So I'm biased, obviously, and I'm going to pitch why I think Pydantic AI is right, why it matched my requirements as an engineer. But I would encourage anyone to go and look at them themselves and decide which one they find easiest to use. We didn't build Pydantic AI primarily to be easy to use on the first initial example. What we built it to do was to be type safe and to be good for building production applications. So that is things like type safety throughout the application. That is things like having whatever it is, 98% coverage on our code base. That is things like all of the SDKs use the same HTTPX network HTTP library under the hood, and so they can all be used in an async manner. In fact, we have our own direct integration with the Google Gemini API because their SDKs still use requests for some reason, and so you can't do proper async with them. But it's also the attention to detail on developer experience that we've learned from maintaining Pydantic for the last 6 years or whatever. So every single example in Pydantic AI's documentation is unit tested. So we run that code and we automatically insert the print statements after the print. And if they change or if they're wrong, we get back an error. So we can't have documentation examples that are out of date with the library. Whereas every single library I've ever used that doesn't do that, they end up being out of date, and you end up scratching your head trying to work out what the hell is going on with this example. Then you realize no one updated it when they changed the API. Now, things like that are commonplace in other languages. In Rust, if you started having examples of Rust code within your documentation, they would automatically be tested if you run cargo test. In Python, it requires a bunch of setup, and we've even built libraries to do that. But I don't think any of the other agent frameworks have got to that level. They're still at the we're going to start adding type hints here and there. I don't know if they all even run type checking properly.
Okay, but so basically, making the experience better for developer, making sure there aren't bugs in their code and there aren't any bugs in the documentation and in the examples.
Yeah, I mean, I think it's mostly things which are, for the most part, are common practice, good engineering technique that are used in most popular Python libraries. It's just that in the explosion of Gen AI over the last couple of years, most of the agent frameworks that have come to prominence just haven't bothered to follow those things. They are, in general, machine learning experts rather than Python engineers who, for one reason or another, decided not to follow best practice. And we've gone along, and we haven't. I'm not saying Pydantic AI's code base is better than HTTPX or Rich or any other prominent Python library, general purpose Python library, but I do think it's a higher quality than most of the agent frameworks. And there are a bunch of relatively reasonably well accepted and quantitative measures that you can think of for that. So, are we linting? Are we running type checking? Do we have high coverage? Do we have proper unit tests? Do we unit test across all supported Python versions? Those things seem like a pretty low bar in some ways. Go and look at some of the agent frameworks, and they're not doing those things amazingly.
So you're building a lot for developers, essentially your main customers, I guess, if we can call it like that, or your main audience are developers, right? Did you ever think about businesses as well, or building more, for example, applied agent applications for businesses using your framework, or is this not on the roadmap yet?
So I think it could be. I think we have to. Our acid test is, would we use it, and would the big companies who do the engineers we trust in big companies find that useful, right? And I've been speaking to one of the large UK banks about the agents that they're building and about how they might use Pydantic AI and how they might use Logfire. They obviously already use Pydantic a lot, so so they already trust us to some extent. Are they really going to go and use a drag and drop agent framework builder to put things into production that are deciding whether or not to offer people loans? I suspect not. I suspect they would rather have that logic encoded in code, quite often Python code, that they can check out, that they can version control, that they can see how it changed, that they know how it's deployed, they know how it connects to a database. it turns out that like software engineers are not just people who are good at typing and who know this particularly odd syntax for defining logic. They're actually experts at defining logic and working out the pitfalls of that logic. And those people want to write code. If you go to an experienced engineer and you say, hey, do you want to go and use this drag and drop interface to build your agents? You're going to get punched on the nose.
Yeah, makes sense. Developers is the right way to go because companies will want their developers to build things for them rather than, I mean, it will be more customizable, I guess, if developers can do things themselves. If you build a platform for businesses, it will be something kind of general that will never really match their needs, but you can still add a few features or make it a bit more custom. So yeah, it's a fine line
Well, I
between
think
the two.
what's interesting is that like code, Python code and TypeScript in particular, are becoming the definition of the logic, right? Sure, you might go and use, I have my questions about how well it will really work, but you can do what people seem to refer to as vibe coding, where you basically ask Cursor to try and build your application, and then when it goes wrong, you feed it back the error and you try again, and maybe it ends up succeeding, or maybe it ends up like taking down the power grid, who knows. But like your definition is still code, and so you still need libraries that code is going to go and use. And if you've got this LLM that currently is not as good as an experienced developer, it matters all the more that the agent frameworks that the frameworks that you're using are of a good quality and don't have obvious foot guns, because you've got an even less intelligent developer in the form of an LLM writing it sometimes. So I think there are some exceptions. So I think, for example, prompt engineering is real, and you have people who don't want to write code, who want to be able to update the prompt and see how that changes. And I think prompt management is something that we're thinking about quite actively inside Logfire, and allowing people to basically go and like tweak the prompt in a particular production application without needing to get access to the source code. But I think that the definition of the tools and the definition of how you make requests to the databases and when you need to use a transaction, that's code.
And so, based on your experience with agent frameworks and agents, what are they very good at the moment, and what do they struggle with, and what's the next step for agents and for Pydantic AI?
Yeah, so they're very good at tasks like extracting structured data from unstructured sources. So whether that is images or PDFs or web pages, agent frameworks are very good at extracting data from that. The simple chat interfaces that we've all got used to in Claude and ChatGPT, you can build with an agent framework very quickly. You can then augment that with tool calls. So you might be able to ask your chat interface, when you're referring to a particular image, please make this image grayscale. That would be implemented via a tool call. RAG is also very useful. So basically vector search and embeddings allow you to do some powerful things that you couldn't do before. We don't yet have a specific embeddings and vector search API within Pydantic AI, but we already have an example of how you would use a native SDK for that, and I think we will be adding that stuff fairly soon. So those cases work well. But then you can go on into the more exciting and more difficult space. So, for example, MCP, Model Context Protocol from Anthropic, is a really exciting project. I've spoken to David a few times who works on that, and we will support MCP within PydanticAI, which will allow you to do a whole host of more complex things.
What is MCP for those who don't know? Can you?
I'm going to do a bad job of defining it now, but it is it's basically a protocol through which agents can, or LLMs generally, can interact with third-party resources like tool calls, but also other things. So they built it particularly for the kind of desktop client use case of like, what things can our desktop client want to go and do? How is it going to interact with those things? Let's use MCP for that, which has some tension with PydanticAI and trying to be type safe and have basically ahead of time definitions of the tools, but we can make that stuff work. But yeah, I mean, you can imagine if you have God knows, let me think of an example. Let's say you're, and I'm not saying this is a good idea, but just to demonstrate the idea, you're using natural language to control a robot. How am I going to do that? Am I going to go and write every tool call for what the robot might do? Or could the robot might basically speak MCP and then my agent might speak MCP, and now the agent can control the robot without needing to write all the protocol. There might also be an MCP, for example, for interacting with Slack, where you could get messages or post messages, et cetera, where again, you don't have to build all of the API integration yourself each time.
Okay, so it's kind of a language to allow LLMs to call tools, and instead of having to speak the Slack language and then the robot language, they have like the same language, and so it makes it easier to integrate tools with LLMs.
Yeah, and I apologize if I've butchered my definition of MCP. I read about it a lot in December, and I have been busy doing other things since, so I apologize if I've defined it wrong, but look up Model Context Protocol and you'll find it out. But yeah, what other things that the agents don't do well yet? So if you go over ballpark 10, 15 tools registered to an agent, it can become quite bad at choosing which tool to call. And so you want to have systems, which we're working on at the moment, to basically decide which tools are registered within a particular call to an LLM, rather than having a full library of hundreds of tools always available, because that just ends up with too much context for the LLM. I will also say that like often LLMs have both structured outputs and tool calls, which are closely related but subtly different. A lot of the less heavyweight models, so for example, the Olama models, the models you can run on your laptop, are apparently good at structured output, but they are not so good at tool calls. At the moment, PydanticAI makes heavy use of tool calls for a bunch of reasons I won't go into, but we need to support structured outputs to allow the like less sophisticated models to work well. It's already usable, but it's not as powerful as it could be.
And so what are your big challenges in the coming months?
I'm not sure. So I think that some of the ongoing challenges around exactly how OpenTelemetry, GenAI at semantics are defined are challenging for us and other companies in similar positions to us. Other than that, I wouldn't say it's so much challenges as loads of exciting things to go and build and trying to work out what to prioritize. So we really want persistence within the state machine, and therefore within agents, so that you can both store the state of an agent to go back and look at it afterwards, but also make agents resilient to failure. So if they fail at some point, you can just go and rerun the rerun the graph, and it will pick up from where it was in an idempotent manner. MCP I was talking about is a really exciting opportunity, but a big piece of work. I think that a lot of people have seen the value in agents or LLMs generally being able to control a browser. That is a hard challenge. You can imagine taking a web page, often that's rendered with JavaScript, so you can't just get back the pure HTML, and then registering each button as a separate tool whilst giving the model a good sense of where the text is on the page so it can decide what to do. There are cool libraries like Browser Use that do that. Unfortunately, they are built on top of LangChain and pull in all of the stuff LangChain has, and we don't really want to make all of LangChain a dependency of PydanticAI. So we might have to go and build our own browser effectively tool set. That's a hard challenge, but a big opportunity. Embeddings, which I talked about, and full support for RAG is another thing we want to go and work on. Multimodal support, so being able to pass images, video, even audio into a model and it process it is another challenge. So lots to work on.
And you mentioned something like when an LLM has 100 tools, it's often overloaded, which makes sense. We know even with large prompts, usually when you have a large prompt with 1,000 instructions, the LLM might forget one or not follow one. So how do you plan to tackle that exactly? And is this something you already support or in PydanticAI?
Yeah, so you can already define tools where they have a prepare method, which basically defines the schema of the tool for that particular call. And if the prepare method returns none, that tool is basically not registered for that particular call. So you could, let's say we do build a browser support, that would be implemented as a tool set. So that would basically say it can dynamically define what tools are available each time you go to make a call to the LLM. So if you go to let's say the index page of Google, the old Google page. I don't know if that still exists, but text box and an enter button. The tools are very simple. There's a like text entry of basically what are you going to search for, and then you would detect that the submit button was going to be effectively executing the tool. But then when you've searched for the thing and you get the results page of Google, now the tools are effectively all of the links you can go to. And so those tools could basically be dynamically available to the model as you navigate. And actually, if you think about how you might use an API, although it wouldn't be as like visually easy to understand, you would get the same thing. If you're like navigating the GitHub API, trying to find some blog post or some issue, you would have the same set of basically tools dynamically coming and going as you navigate.
And so how do you deal with that exactly when you get all those links that you need to search for? How do you know, how do you retrieve the relevant information? And
so how do you extract the links from the page and work out what the tools are? I think that's a hard challenge. I'm not going to claim we've implemented it yet. I mean, I think the very simple case of like a Wikipedia page with a bunch of links, it's relatively easy to imagine that like you would, well, even there it's hard, right? Because you might give it the whole page as context, but then you would say the tools are the following hyperlinks effectively, and maybe the text around them to give them some context. But if you're trying to, I mean, I saw browser use was trying to be able to control Google Sheets. Now we're in a completely different world of what all the different buttons you might have available, all the different tools you might have available. That's a much harder challenge. So I don't know the answer to all of it yet, but like, I mean, the API to basically say dynamically decide what tools you're going to register is relatively easy. Actually building the thing that goes and registers them, much harder.
Okay, no, that makes sense. Thanks. I think we had quite a deep dive into PydanticAI and agents. Promising field. Everyone talks about it in 2025. Feels like it's going to be the next big thing. So yeah, looking forwards to it.
I think one thing I'll add, I still think we're relatively uninventive, uncreative about the things you can do with LLMs. As in, I think an awful lot of it has come down to like structured data extraction, chat interface, coding copilots, maybe a couple of others, but that's kind of it for a lot of the time. And there are so many powerful things that LLMs can do. So, for example, you can imagine someone landing on a SaaS page and basically building their dashboard for them dynamically based on their previous interactions, maybe even using embeddings to define people's set of preferences, which I know the likes of Instagram are already doing, right? If your preferences inside Instagram are not stored as a bunch of like, yes, I'm interested in pictures of sheep. No, I'm not interested in pictures of cows. That's an embedding that defines effectively your set of interests, right? And you can think about lots of SaaS applications going that far and making those things easier. I think we're very early on in the process of working out what things people are interested in. In the things we could potentially build on top of Gen AI.
I think I agree with you, and I think that's also normal because LLMs are only 2-3 years old, so maybe a bit older, 4 years old. But yeah, it's very new, and so first of all, we need a bit of time to get creative and try new things, and also the technology is evolving so fast that you get a new model, and then you see other opportunities, and then a new model and other opportunities. So definitely, like so many things that can be done. We're only scratching the surface. I feel like for example, tabular models. We're still using XGBoost for tabular data. I mean, I work in consulting, and XGBoost is a model that we use a lot, and I'm pretty sure that LLMs can do something here. There are some companies that are trying to solve the problem, but it's still very early stage. So definitely lots of things, even behind text and images, that can be done with Gen AI.
Right, and one of the other things we don't know yet is like what LLMs get better at so fast that there's no point in building abstraction layers for, and what things are LLMs going to remain bad at for long enough that it's worth building the abstraction layer. So, for example, is it worth writing lots of custom code to extract all the links from HTML to present them to a model as tools, or can we just get to the point where we dump all of the HTML or even an image of the screen to the LLM, and it's cost effective, fast, and reliable enough that it'll basically work out where to click?
No, it's a good point. And that's why, have you thought about, so in this case, like you're kind of, it makes sense, it's an agent framework, so you're dependent on people building LLMs, companies like OpenAI, Google. Have you thought about building your own LLM? Because if you can control, like, obviously I know it's very simple, not simple at all, and requires a lot of money, but if you know how good your LLMs are and you've got also the agent frameworks, you kind of control the entire pipeline and can anticipate those things a bit more.
So no, we haven't. We have quite good relations with some of the foundational model companies, and we're a long way from building one. I think there's a really interesting question, right? Like, where in the stack is the like value gonna build up? Like, so you have the NVIDIA, the hardware manufacturers, then you have the foundational model companies, Anthropic, OpenAI, Google, etc. Then you have the kind of enabling technology layer where I would put PydanticAI and to an extent Logfire, right? And then you have the people building the end user applications. So the likes of Harvey or 11x, right? Who are building applications on top of this stuff. In which layer is all the money all of the value gonna basically congregate? I don't think we know yet, right? As in, obviously, NVIDIA is incredibly valuable. OpenAI is incredibly valuable. Some of those companies at the top level have got super valuable. LangChain is probably the foremost of that like third layer, but they're nothing like as valuable as the foundational model companies. So I don't think we know yet where you want to be, basically.
But building an LLM isn't on your roadmap yet.
Not on our roadmap yet. I mean, like, maybe one day we might host one of the, I think the open source models are interesting because they basically, make potentially our slice of that pie like more important, but we're a long way away from it right now.
So just want to finish the episode with two career questions. Before we end this conversation. The first one is, so this show is called AI Stories. Can you tell a story about yourself? It can be anything, something funny, a mistake you've made, something you learned, but just, one story.
I don't know that I sort of touched on it earlier, but the early days of Pydantic V2, I had just quit a job. I'd had a really unpleasant job with an awful boss, and I like threw myself into coding, in particular into Rust, as a like way of distracting myself from that whole experience. And what came out was eventually Pydantic V2, which we released like a year and a half or nearly a year and a half after I first started working on it. But like I had no idea where that was going to go. And what's weird about Pydantic V2 is no one would ever like approve that budget in any normal scenario, right? It takes like some weirdo with a determination to do it for that to happen. Because if you're in a startup and you're like, I'm going to spend the next year and a half building a somewhat faster, well, massively faster, but like fundamentally similar validation library, there's no financial reason why you would go and do that. And yet, obviously, it's turned out brilliantly for us, and it's cemented our position in the AI ecosystem. But it basically came from this, just like my determination to how good can we make Pydantic. So I think there's value in just like doing the thing you care about as well as you can, and sometimes you get lucky, sometimes you don't.
So let's finish the episode with one advice. If you had one advice for people to progress in their career, what would it be?
I suppose I would follow on from what I've just said now, and put your effort into getting good at Python, and like put your effort into getting good at Rust if you so wish. It will make you a better Python developer, but like don't think that you need to leave Python to write performant applications or have a like successful career, because you can do extraordinary things with Python if you know how. And I see companies like Lovable claim they're like moving to Go because they need the performance, and I'm 99% sure if you took half of our team and put them there, they would be able to fix those issues and build something just as performant in Python. So don't believe all the hype around other languages. Python can do almost everything you want, and if not, go and learn Rust.
Well, Samuel, thanks a lot. It was great to have you on the show. Have a great day, and hope to catch up very soon.
Great. Thank you so much for having me.
Thank you.